Hi, everyone. Welcome back. It's my pleasure to introduce Chris Calderon, an Enterprise Technical Solutions Architect at Red Hat Tech Sales, where he plays a role in the partner ecosystem and Intel partnership, leading solution engineering and go-to-market initiatives across North America. With a decade of experience spanning healthcare, retail, energy, and government, Chris has worked extensively in enterprise architecture, networking, edge computing, and ML ops. Prior to Red Hat, he was a technical consultant at Philips Healthcare, specializing in enterprise scale solutions. Today, Chris will walk us through the full circle developer experience using Podman from AI PC to OpenShift AI. Please join me in welcoming Chris Calderon. Over to you, Chris.
Thank you, Susan. Again, my name is Chris Calderon. Thank you so much for being here and having me. Very excited to talk to the Intel community and all the developers at large. Today, hope to give you a good insight into Red Hat and some of our product portfolio around AI and some interesting ways we can enable developers to use the tools available a little more efficiently and bring that value really to customers and the community alike. Because again, Red Hat is an open source company. A lot of our products are developed through there. So we always want to give back to the community and really inspire that developer change. So today we'll go over the full circle developer experience, introducing Podman and a few other things, hoping to really highlight the ability to use AI PCs in the enterprise. Quick high-level overview of the agenda here for you guys to refer back to. I'll try to cover a few topics at a time. So AI, it's snap magic, right? A few years ago, it might have looked like magic. Nowadays, we know it's just math, right? It's like any other workload we can think of. The future of it is, still deploying code, serving models is just another application. But as we know, it probably just requires a little more intensive sort of workloads, right? So again, the business metrics are usually revenue focused, but it's also about optimizing, ending up in a better place than we were before. But ultimately, we have to mitigate risks. There's a huge change in climate around virtualization and a few other topics. And as technology advances, we have to be able to do these scalably and safely, while still empowering our developers to really drive those business critical applications. So our bread and butter here seems to be a Red Hat OpenShift. We have also released Red Hat Enterprise Linux for AI. And these are all both turnkey platforms derived from open source, allowing developers to have tools and out of the box experience alike on multiple different installation scenarios, anywhere from bare metal to cloud, really supporting that multi-hybrid cloud elasticity that Kubernetes can provide. And AI is at the forefront of Kubernetes as well, serving models, at smaller intervals and with using smaller resources seems to be key right now, because a lot of enterprises have to invest a lot into just getting a single AI pod, anywhere from GPU cost to the actual power consumption. So the more we can curve training and the more we can curve maybe even just certifying and really empowering the workforce to get familiar with tools, the easier we can make that. Really lowers the barrier to entry, kind of helps everyone all together. Because right now, a lot of enterprises need to bake in their data into some of these models, right? Out of the box, some of them work really great for some of the general, party trick at a party sort of thing, text to image generation things. But to really provide business value, we really need to be able to align our data and train our data sets to these models to use them at scale. So we're really trying to empower these, again, application developers to be able to do this out of the box. Now, spinning up cost in the cloud or maybe the data center is very expensive. And let's say for the smaller workloads, we need to start somewhere, right? We need our developers to be able to prototype and test locally, possibly with the smaller data sets, and eventually scale that out. We want to give them the confidence to be able to do that locally and have it be seamless into the cloud with not too many stepping on too many toes. Because again, we're going to have infrastructure teams, networking teams, security teams, data scientist teams who might be hindering in a traditional IT environment. We want to really change the culture of how applications are deployed, and that's all brought up through Kubernetes as well. So we're looking, where do we start at step one, right? Let's say we have the foundational, if you're running a single VM using our Red Hat Enterprise Linux for AI, or if you're just going to skip right to the data center at the larger scale and go into the OpenShift AI, which is the Kubernetes base, which is the full platform. Where do we start as step one, right? What if we want to train something locally? What can we do at a limited scale? it's your laptop, right? An AI PC. They're getting smarter by the day. Intel's releasing some amazing new features inside of their AI PCs and some of the chipsets that are available to there. Or even if you're just running a regular Windows laptop and you want to try something locally, we're going to kind of go into Red Hat Enterprise Linux AI first because I want to tee up our Instruct Lab. But another thing to point out with our RHEL AI is the ability to do things like image mode and really make it a lot more lightweight, be able to have a single VM, have a lot of the features baked in from some of the model serving tools and some of the nuts and bolts, things like Pytorch and some of the other notebook functions, as well as now, since OpenShift AI is a bring your own model sort of approach, meaning we don't necessarily make models, we help you bring your own to third-party ISVs or in-homegrown ones, but we actually have the ability to now announced at last year's Red Hat Summit, the IBM Granite model. This is completely free. It's based off the Apache 2.0 license, and it's free to consume for all the public there. And it was just our way to kind of show that we really are invested. We took this, trained it, and gave it out to the public for them to be able to use. This comes also included with Red Hat Enterprise Linux AI. And so how are we using this to, aside from just giving a free model to the public, what are we doing to invest in it? The other thing that was mentioned in the previous slide was Instruct Lab, right? How can we train these things a little bit more locally? How do we not spin up too much of the cost in the cloud? Well, using Instruct Lab, this is, again, very open sourcey, a community approach to training, large language models at scale. Developers alike, like you and myself, could come into this lab, pool a model that's being currently developed through, Instruct Lab pools and registries and such, and train our own data sets against these models. And then it kind of, rinse and repeat goes back into this methodology. Now, you can also deploy this, although this is a free feature you can run on your laptop and, run it through, whatever browser interface you'd like. You can also do this within your own internal company as well. If you wanted to use the same methodology and deploy this inside like a RHEL AI VM inside your data center, you definitely could. And we have had customers do the self-managed version, again, not using the Red Hat and IBM dependent Instruct Lab, deploying within their actual data center, and we've had a lot of success, right? So we've had customers take this methodology and really bring a lot of business value to theirs by being able to train their data sets using this out-of-the-box tool that curves some of the barrier to entry, right? But let's say you're still not ready for taking it all the way to the data center. Let's keep it local at the laptop level. You tried Instruct Lab, but you're saying, you know what, I'd like to use maybe a different model. So running the models locally allows you to, again, reduce cost. Being able to port it to the data center with ease and train it with your data sets is super critical for a lot of companies nowadays because of how expensive it really is, right? So I want to introduce to you Podman-Desktop. This runs on any laptop you have. You can have it on your Mac OS, your Windows, or any other distribution operating system that you have. This allows you to train things versus your data sets and, again, deploy containers locally and statically, meaning that we're able to have lightweight container images and have that be able to be released through, a GitOps feature or some other webhook, or create it and throw it into a pipeline somewhere down the road, right? This allows you to do this all locally at your laptop, test, fail quickly many times. When you do spin up that multi-cluster environment, you're able to hit the ground running a lot more quicker and a lot more cheaper. And it's kind of fun as well, right? We also have the Podman AI built into this as well with a couple of other references and registries so you can kind of get started a little bit quicker. And this is a really fun thing to do just locally if you're, have an afternoon free and you want to play around with a couple of random models. Very fun to trade it against your own data sets. And we have all the, onboarding tools and features to be able to import it into a larger data set, right? Into a bigger environment using our extensions catalog. We're also bringing a lot of accelerator support for some of the most popular accelerators. And these are plugins you can download right from like a quote unquote marketplace, right? To be able to, really make this tool a little bit more robust and have a more seamless on-ramp feature onto something like OpenShift. Again, reducing that barrier between the data center and your local static things makes everyone a little bit more happy and allows you to experiment a lot more quicker. So let's say you're trying to take it past just running a single VM. You're taking it past the laptop stage, right? We're going AI PC to the data center, skipping Red Hat Enterprise Linux AI because we covered that. I want to show you the real big, robust solution that we have currently, which is our Red Hat OpenShift AI. This sits on top of OpenShift as an operator. An operator, you can think of it like an app on your phone. Think about if you're running like an Apple iPhone. If you want to use YouTube, you spin up your Safari browser, type in YouTube. It works. It's a friendly interface, but it's not completely seamless. You go to the App Store and download the app directly. It's verified by a third party. It runs a lot more smoother. That's exactly how OpenShift AI installs on top of OpenShift. So when you're ingesting OpenShift AI, you're also ingesting OpenShift. All the tooling capabilities right under it are completely available. But OpenShift AI does run as a separate console because we need to include all of the features and subsets and other technologies we're baking in, really separating the two teams and having them be tied in on the back end through some API functions. But again, you'll still be able to use all the out-of-the-box features, the comprehensive platform from creating CI/CD pipelines, some of the observability through like Prometheus and Grafana. You're able to do things like service mesh, serverless, all the regular things that you're probably doing already in your environment and the developers are using to deploy applications. And again, deploy it anywhere. Now, within OpenShift AI, again, a separate console, you have your own dedicated view. There's things that are called data science projects. This is kind of your one-stop kind of place to be able to create multiple namespaces, assign them a little bit of segmentation across two different workloads that you're actually running. And this is really going to be your working place. And again, anything that you create in OpenShift AI is looked at as an object inside OpenShift itself. Again, on the back end, tying it together, but allowing data scientists and other developers to create a little bit of that separation. Some of the features kind of built into it is things like with our workbenches, you're actually able to select your own notebook images, anything from like a Jupyter or VS Code. You're able to use different runtimes, things like OpenVINO, which we integrated heavily out of the box with OpenShift AI and Intel, thanks to them. Things like Pytorch, Tensorflow, and any of the other really good ones that are very, very popular in the industry right now. We also have things like K8serve and Model Mesh for model serving, and any of the other little nuts and bolts. And again, these are all included free and backed up through SLAs and through the support system of your Red Hat OpenShift AI subscription, meaning that Red Hat will back you in all these in production environments. Really takes the DIY out of Kubernetes and the DIY out of AI in general. So again, we're talking about your data science project, and inside this, what is it that you kind of get? What are you looking at in your day-to-day is going to be your workbenches, your storage, data connections, pipelines, and some of your model servers. There's a few other features we'll get into, something around settings and observability, but let's go ahead and look at workbenches for now. In your actual notebook images, you're actually able to import them directly into the workbench. That's going to be your inside of your project where you're going to be attaching things like your storage, your data connections. The data connection could be like an S3 or an object or a registry, right? You can plug in your own images, bring them down from Git, or you can bring them up through like a Jupyter notebook. And inside Jupyter Notebook, you're able to execute all of the different inferencing and training, have your checks and sums there, and then deploy them into OpenShift through things like data science pipelines. So speaking of that, again, using Jupyter like a base notebook image, you're able to import things like CUDA and Pytorch and TensorFlow and use all your regular automation through Python or whatever have you to kind of bake it into a single place. You're able to define a pipeline and bring it in, kind of taking note to, in OpenShift, you have your regular CI/CD pipeline based off like things like Tekton and Jenkins and things like that. We have a similar function here within OpenShift AI that is completely separate as a data science pipeline, meaning you're able to take different steps of automation for different code checks and really speed up the application lifecycle of your model and whatever it is that you're deploying. So you can define it within Jupyter Notebooks, use the pipeline editor features, and actually import them as code directly into OpenShift AI. That creates a data science pipeline, multiple checks, make it a little bit easier for you to kind of do your checks and sums. It's good for security, it's good for operations, and it's also very cost effective. You're not spending a lot of time spinning up multiple different interfaces trying to stitch this thing together. There's a lot of automation on the back end that allows you to do that. Again, enforcing and kind of embracing that GitOps feature that you get from regular OpenShift. Working whether you're in the UI, all the way to the YAML, and anything in between. You're able to import any of your favorite runtimes, any of your favorite languages, and deploy them as code very, very quickly. Something also available is something that we're baking in is the model registry, where again, through code, you're actually able to bring it down, whether it's trained or not. You can have it sit within the UI. Makes it a lot easier for data scientists to really be able to poke and look at it a lot more quickly. And also your operations teams to be able to kind of assign any API functions, make it a little more lightweight. If you need to deploy or migrate it live into another cluster, you're able to back it up with a lot of APIs, adding that extra layer of automation and storing it as an object. There's also all the monitoring and performance. A lot of customers are trying to decide, is this training or inferencing going to be using more of the CPU, GPU, and although this can't necessarily automatically detect which one you should do, as long as you're following IT best practices, you're able to kind of, react on the fly, if you will, and check some of these performances and divvy them up wherever it is you need to kind of push them towards. And, it really just helps track and some of that resource consumption, making, again, that barrier to entry a little bit lesser by, these out-of-the-box features. Also being able to distribute workloads, that's a feature of regular OpenShift in general, but we've, again, brought it to OpenShift AI to be able to distribute to other nodes that are perhaps being underutilized using, typically you do it through like a descheduler or something like a DRS, right? But in OpenShift AI, we have our own feature, and it's based off of, RHEL clusters, and using Codeflare, you're actually able to tag those and distribute them at will. Very, very good, again, for keeping costs down and spinning, not spinning things up inside the cloud. Couple extra steps here if you want to go ahead and try this out yourself. We kind of took you through the journey of, deploying locally on a laptop AI PC, being able to create a static workload on a container with things like Podman, or take it a little step further, use things like InstructLab and train on a Granite model to the community version, and of course onboard that onto the data center, whether you're running a single VM through Red Hat Enterprise Linux AI, more of a foundational approach, or all the way to OpenShift AI, sitting on top of OpenShift, allowing you to use all those open source features and some of that elastic services. And again, ultimately deploying wherever it is you need to do to be able to, really unlock your business potential. That's all I have for you guys today. I'll go ahead and kick it off for a couple questions if there are any out in the crowd.
Hey, Chris. I am not seeing questions yet. I'm checking that. So let's give people a minute or two to think about questions. What I would love to see is if you have the URL to the extension catalog, if you can post that in the chat.
Sure thing.
I was trying to look it up to go ahead and push it out to the audience. And then you went off that screen on me.
No worries. And you're talking about the Podman-Desktop extensions, am I right?
Exactly. I have something, but I'm not sure that that's it. I have the Red Hat extension pack for Podman-Desktop. Is that it?
Yeah, that's one you can use, absolutely. There's a few of them, so it depends which ones that you're looking for, but here is a good introduction. It has a couple hyperlinks into it that you could, I'll go ahead and drop it into there, and you can share that with the crowd.
Hey, Chris, I put a question on the chat if you want to look at that one.
Sure thing. Susan, are you able to see that one by any chance?
Yes. So the question is, they have a Lunar Lake laptop running Linux. How can they take advantage of Podman-Desktop and running Fedora Linux 4.1?
Yeah, absolutely perfect. Fedora is one of the upstream projects we actually use for our regular Red Hat Enterprise Linux. So a lot of compatibility there. You can actually pull down Podman through probably a CLI utility, or you can download it from the actual Podman website. The link that I sent will show likely another fork link that you're able to download it locally. And you can just run static containers on your Fedora PC or laptop. And again, we have that Podman AI Lab, which is another, I don't know if it works as an extension or perhaps just another console interface that allows you to use some tips and tricks that the community has brought up. Because again, Podman is community, it's for free, meaning that we have a lot of people that are doing everyday tasks on there. We're actually preparing for some demos at our next show here at Intel Vision coming up in a few weeks. We'll be demoing that, and that will also be available online, where we actually demo Podman statically, training some AI workloads. And the Podman site has all those features available as well, and has some good resources for you to get started on using static workloads with containers.
Any other questions from the audience? I just saw something flash by. 1 second. Let me just make sure. Nope. Okay. All right. If we don't have any more questions, I will say that we are done with the Q&A. And I would like to say thank you, Chris, so much for being with us today. We are now coming up to our last session of day 1. Oh, hang on, before I do that, Chris is going to be talking tomorrow as well on day 2. And let me get your topic up, Chris, just to remind people to stop by tomorrow. And it is going to be, Chris is going to be talking about building a RAG pipeline with Red Hat, OpenShift AI, and OPIA validated platform. So you're going to see Chris again tomorrow as well.
Thank you. Yeah, good call out, Susan. Yeah, that will be a little bit deeper into OpenShift AI, and I'll show you how we actually demoed that. We created a chatbot, put 2 of them up beside each other, and threw a RAG pipeline in the second one to kind of stop hallucinations. So showing you in real time how to train an actual chatbot using OpenShift AI.
Yeah, so I look at today's presentation as the warm-up for tomorrow's application of Podman. So that is going to be exciting to see that in more detail. Now, we are now up to our last session of the first day of the AI Dev Summit. And Catherine Druckmann and my very own co-host, Sriram Krishna, are going to present the session, Simplifying Generative AI App Development, Standardization Matters. So you'll need to leave this session and go back to the agenda and join their session. Thanks again, Chris. I really appreciate it.
Absolutely. Thanks, everyone.
All right, bye.